Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, what I want to do is I want to cover the basics of map projections so that you have at least a conceptual understanding of what a projection does and why there are what are called distortions, which we'll talk about later, in any type of map projection. And so what I want to do is I want to talk about the basics of map projections. So at a fundamental level, and I want to make this known up front, right, map projections are trigonometric equations. Right? And again, you have to remember at the most fundamental level, it's about taking 3D coordinates. So this is latitude and longitude, and making them into 2D coordinates, which is x and y. Right? And we do that through trigonometry. But we're not going to talk about trigonometry. Right? That's way more in depth and too advanced for this course. And honestly, it's not that important that you understand the equations. What's more important is that you understand conceptually what a map projection is doing, and that you are able to develop a system to determine the map projection that is best for a given application. So let's go ahead and sort of, setting the math aside, conceptually outline what a map projection is doing. Right? And it's really done in a series of steps. And these are conceptual. So the first thing that we do is you can think of shrinking down the Earth to whatever size you want the final map to be. Right? And we call this the reference globe, right? So shrink an imaginary globe to the size of your final map. Your desired map. So two things. When we say size here, what we're talking about is something called reference scale. And we've talked about scale in the past, right? Scale is just the relationship between the size of objects in the real world and the size of objects on the map. So the first thing that we're going to do is we're going to decide what that scale is going to be, and we call that reference scale. This whole thing, this imaginary globe set at the size, we call this whole thing, this is what we call a reference globe. We'll call this whole thing a reference globe. Now, I'm going to draw, right? So if we can imagine that this is a portion of the reference globe. Okay. So the next thing that we need to do is we need to imagine that the whole purpose, or the way that we're going to project the map, is we're going to take our reference globe and we're going to wrap an imaginary sheet of paper. We call that a developable surface. We need to wrap that imaginary sheet of paper around the reference globe. right? And we call this imaginary sheet of paper, we call this a developable surface. Make that a little bit cleaner. Right. Right, and so this thing right here, right, this is the developable surface. Okay. 3, place a light source. Somewhere in the system that shines through the reference globe onto the developable surface. Let's make that a little bit cleaner. Right? So we're going to place a light source somewhere in the system that shines through the reference globe onto the developable surface. And so what we do with this light source, right, we call this light source here, this is the projection surface, or the projection source. Right, so if I make the projection source in this case orange, right, I'll put a star here. And the projection source is going to shine through the reference globe onto the developable surface. Right? I'm going to scroll down just slightly here. Step 4, right, is trace the outline of the reference globe on the developable surface to make the map. Okay. So at a conceptual level, again, behind the scenes, all this is trigonometric equations, and you can certainly go into the internet and look up the equations behind any map projection to see the math behind it. But at the end of the day, what's more important is understanding conceptually how we view these map projections. And what we think of them conceptually is we have a globe, right? Let me make that. There we go. Right, that we have a globe that we've shrunk down to meet the size that we want the map to be. We take a piece of paper called a developable surface. We wrap it around the globe in some way. We'll talk about how we can wrap it in the next section. We place a light source somewhere in this system, either inside of the globe in some place or maybe outside of the globe in some place. And the idea is that we shine from the projection source through the reference globe onto the developable surface, and then we simply trace. Okay, so at a sort of conceptual level, this is what map projection math is doing. All right, it's just tracing the way that the reference globe at the size that we want is being projected from a light source onto a piece of paper called a developable surface. Okay, so hopefully this makes sense. In the next video, we'll talk about some of the details of this and how this concept can be categorized. This concept of developable surface and the relationship between the developable surface and the reference globe can be categorized, as well as what happens when we have these gaps between the reference globe and the developable surface, which we would call this difference here is going to lead to something called distortion. So as always, if you have any questions, please reach out. Thank you.